You want to lead it off like last time?
We'll wait till people. Okay.
Yeah, you're the first.
We got it going.
Oh, we got it going? Want some help?
Yeah, somebody help me out.
Hey Blair, you're not coming to my talk? Fine. See if I get engaged again.
He's
going to get trolled the whole way.
Yeah, one of our speakers just walked off, so
Okay,
great.
what's going on?
he's going to get Blair. I'm thinking, yeah. Are we still rolling?
It's still rolling, yeah. I said
Okay.
I'm sorry. I started it up.
I got you. Well, this is...
We can trim it.
Yeah, we can trim it down a little bit.
Make sure you speak into the microphone if you can, though.
Okay, no problem. All right,
Wait till Bill gets back.
he's on his way.
Sorry. This is the hallway trolling.
Here you go, man.
How come I get to go first?
Because you're our leader.
Hi, I'm Bill Gardner, and I teach at Marshall. Oh, very good. Slides. Does this have on my bio on it too? So I'm a bunch of things. I'm a co-founder of HackerCon, co-founder of 304 Geeks. I also am an organizer of AIDE, the Appalachian Institute of Digital Evidence, which has its conference every spring at Marshall University. I teach digital forensics and information assurance at Marshall University, and thanks to all the students that came out for this conference, there's no extra credit. Sorry. I'm also a thought leader in the cybersecurity space. Drink. Oh, well, hang on.
Hi, I'm Sean Jordan. I'm a digital forensics and information assurance major. And I co-authored Network Scout, I guess.
I think the next one's a Twitter handle. Yeah. All right. You can follow Network Scout on Twitter. If any of you guys have a Twitter and know what that is, we'll make sure that we update it with everything that we do. And by the way, hi, my name is Aiden Somerville. I have the handle RageAndAsian18 on Twitter. I'm a digital forensics and information assurance major at Marshall University. I designed the website and the server to make everything work together. Okay. Now, before we get started, we'd like to give a special thanks to the Marshall University and the College of Science, the Dow Chemical Corporation, and the state of West Virginia for giving us money for letting us further our horizons in network security. All right, intro. Yep, here again.
You're not supposed to say okay intro. So basically, this project is the result of a late night Skype chat between me and Justin Brown. You all know Spritle. Spritle's the guy that you usually see at conferences behind Hackers for Charity table. And we had this idea, and we originally were going to do it on the Shiva plug. Shiva plug was kind of expensive. The development tools wasn't all that great. And I said, hey, Raspberry Pis. So we're like, that's a really great idea. And no one ever did anything with it. So after I started teaching at Marshall, these guys, you know, I know Sean had an interest in Python, and Aiden actually developed my website at Marshall, my personal website. I'm like, hey guys, why don't you work on this? I have this idea. And they basically took a very simple idea and went to town on it. So they worked all summer. Thanks to the funding, they actually got paid to do this. This was their summer job. And then I really tried to instill in them that we're using open source software. The basis for this is Dave Kennedy's artillery, sorry. Yeah, I do need more Monster. Artillery, of course, is a Infected Mushroom song. So we like killed it at Derby when they played artillery. But it's a very simple honeypot, and that's basically it's a honey. This project is a honeypot running on a Raspberry Pi. And what we did is we basically borrowed the idea of the Rugged Pi design. Thank you. I'm really out of it today. The Rugged Pi design from Hackers for Charity, which Johnny and Sam Kinch did, to deploy in Africa as an educational server. So we're like, thank you. Is this mine?
Yep.
I can't smell liquor in it. So we really like the design, so we basically took it and we made it less expensive. So the idea is to put in the Pelican case is that when you put something in a server room, most server rooms are okay, but some of them are under bathrooms. They're dusty. They can get accidentally wet. So the idea of this is you plug it into each logical or physical subnet of your network. Why are you plugging it into the inside of your network? The idea behind Network Pi is that it watches the inside of your network. Everyone's worried about the edge of their network. They're buying blinky light boxes. The network edge is where all the defensive money goes. So we wanted to build an open source, free as in beer and free as in speech, something that you can build yourself for a lot of money, and you can throw it inside your network. You may only throw one inside your network, but you might throw one in each of your subnets. And so it watches the inside of your network, so when somebody clicks on a link or opens an attachment, and if that's encoded against antivirus, because you'll have guys who'll stand at HackerCons all day and talk about what jokes IDSs and IPSs and antivirus is, and it gets past your security awareness program, because humans are the weakest link, and then it starts to pivot an attack, this will see the scans. This will see it pivoting an attack. So you know that you have a problem. You can take that computer off your network. And when you deploy this thing, you theoretically shouldn't see anything. Your network should be relatively quiet at rest. So if you see Network Scout, even one alert, you need to go look at it. Now, one of the things we found in testing, and I've been testing this longer than they've been working on it, because I basically tested the idea before we deployed it, was that you'll see things like Active Directory Exchange, well, not Exchange, but Active Directory servers will look for Windows machines, so it will scan the network. So you'll usually see a false positive from like Active Directory domain controllers, but you can take those out. Now that's the problem if you take those out and whitelist those. If your Active Directory domain controller gets popped, you're not going to see the scan. But sometimes there is ways of adjusting this. And basically what you're focusing on here is client machines. The people that are surfing the internet, the people who are getting email. You're kind of watching the inside of your network. So actually that's my whole part in this talk. I'm here to introduce these guys. They did the grunt work. I'm just hanging on their coattails. So actually I'm going to get my stuff and go back there.
Thank you so much, Bill. All right. Yeah, you got the part.
So Bill kind of went over what it is, and we're just going to go through this real fast. What is Network Scout? It adds an additional layer to your security. So distributed honeypot. So put this on your network, and it all comes back. So you have all these subnets and artillery's running, and if artillery gets a flag, you don't go to each box. It all reports centrally, kind of like this. So see, it all comes back to the central server. And now we're going to talk about the hard side.
Hello. All right, before we begin again, I'd like to give a special shout out to Hackers for Charity. As Bill described, we used our design based off the Rugged Pi design, especially thanks to Sam Kinch and Johnny Long. All right, I think we're done with product disclaimers for this one. All right, the required tools that you're going to need. You're definitely going to need a soldering iron, a drill with 5/8 and 1/4 drill bits, clamps, files, and we also found out the hard way that if you use a dermal to cut the plexiglass, it'll produce this poisonous gas that may get you kicked out of wherever you're working. For us, it was a church, and they weren't really happy about that, so just word to the wise, don't do that. All right? right, here's the pieces. We have all the pieces that you're going to need up on our GitHub, and like there's a lot of them, but at the same time they're in a nice ordered fashion. There you go. You can find most of them on Amazon.com. You can find the standoff screws and the breadboards at your local Radio Shack, and you can find the pass-throughs on the back at Home Depot or Lowe's. Another thing is, we would probably want you to order the pins about 2 weeks in advance, because it took them about 2 weeks for them to come in. Like after we had got all our parts, like they came in last, and it was kind of annoying.
They come from Hong Kong.
Yeah.
So it takes about 2 to 3 weeks for them to actually arrive at your door. But shipping's only 99 cents. So.
On the APT stuff. Drink. Here, as you can see it being passed around, the breadboard, Raspberry Pi, B or B+, the LCD screen, and the shutdown button are all attached to the plexiglass. You use the drill to drill the holes and to be able to pick it off with your finger and analyze it or fix anything you need. Alright, Network Scout. One of those boxes is about $127.74 to build. We found that it was about $30 cheaper the next time you build another unit, because you had pieces left over from the first build that you're able to invest in the second one. And most recently, the Raspberry Pi A+ has come out. Now, we haven't done any testing with the A+ or the A, but we're planning on buying more and testing out this summer, so that way it'll work, whatever Pi you buy, it'll be good. The how-to guide is available up on our GitHub. You just got to go to GitHub and type in Network Scout. The LCD instructions are also included, and they're provided by Adafruit, and it'll give you a good walkthrough about how to connect it and solder what you need to solder. All right, software side.
Real fast back to hardware. One of the reasons we chose that design is it's module. So if something goes bad, you just need a screwdriver and the part, take it out, fix it, 30 minutes. Another thing with the A+ is the cost went down $15. So that means you can build 2 for about $200. So our goal was to hit about $100 per unit, and where these kind of work in pairs, we kind of achieved that with the price of the Pi. So back to the software side, we have to give a shout out to Dave Kennedy and the Trusted Sec team. They build artillery, and we're a branch off of artillery, or a layer on top of artillery. So special links to them. Okay, so here's our GitHub. If you go to the wiki, we have the documentations available on how to build one of these. You can also see the LCD instructions, and due to a recommendation at DerbyCon, we also posted images up. So you don't even have to set up artillery or Network Scout. You can download the server and the client image and run it right on, or put it right on your SD card, slide it in the Pi, boot up just fine. So, when you go into the Network Scout folder, you're going to find 4 folders here. You got Stuff, Startup, Source, and Website. If you look in the Stuff folder, you're going to find the artillery logging function. We'll talk about that here later. The startup, the init.d scripts. Your source has your core.py function that has all your functions in it. And then finally, we have a website, and that gets moved over to var/www during setup. And then files inside there, you're going to see a network NS setup file, server, client, which we'll go into detail. Then we also have a controller for the LCD screen and a shutdown script that runs constantly to tell if the button's been pressed. And your config file is located inside the NS folder, and it has the IP address. So when you get your Network Scout, the only thing you'll have to change in the config file is where to send the packets to the server. So get your server, set it up, you'll have an IP address, and then you tell all your scouts, hey, send your packets here.
Alright, I'll go over the server with you guys real quick. Here's a Python script I wrote to set up a TCP connection between the clients and the server. It can listen to up to 4 nodes at once, so that way it avoids like data traffic jams, so you'll receive every warning without fail, nothing will get dropped. everything that is received is written to a received info file in the stuff folder that Sean wrote or created, and we break up the string once it's in the received info with comma delimiters, and then we inhabit the variables that we put that will like be displayed on our website, and we make sure that the connection is good and then we received everything. Then we do a try accept loop to make sure that we can commit the changes if everything's all right, or we can roll back to the previous state, so that way no error data will be displayed. And after that, we close out the connection, and then here you go, Sean. Back to client.
So the client software, pretty simple. We read the configuration from the config file for the IP address. We make sure that Network Scout is actually installed. So check that. If not, it'll run the Network Scout setup. And then this will loop through. It checks the size of the log file. So if it's over 10 megabits, it'll say, hey, time to send this. We got some information in here. It'll try to send it. If it fails to send the log file contents, it'll throw the exception. But if it succeeds, it will actually go through, open the log, clear it out. So it's already on your server. We go ahead and erase it from the client. It makes it easier to manage data that way. And then we wait a minute, and then it checks again. So this is checking every minute. So when your server is getting this information, you're pretty much up to date till the minute. So, and this is what it looks like to send the file. We open the socket, connect to the server, send the contents, and then close it. So, and then some of the challenges we had with Network Scout. Python was a big challenge for us. Going into the summer, we thought Artillery had a lot more more functions than actually did. We thought it would automatically send the file to the server, have that remote functionality, and didn't really work. And we were sitting there like July with a deadline of September, and we had basic Python, but not anything in depth. And we're sitting here, we're like, Aiden, you know any good Python code to throw in here to make it work? So, yeah. So, gotta thank the open source community for all their support and your endeavors with that, because Stack Overflow is your friend when you're getting error messages. And then,
all right, for the issues of finding the IP address to put in the server, so that way you could listen for the nodes, we provided the LCD screen that will display the IP address of each Pi, and it will also, if you have the client software downloaded on it, tell you if Artillery is up and running, and or if it's the server, then it'll tell you if the server's up. Another reason that we did this is because if you tried to scan any Network Scout client, it would automatically trigger Artillery and ban you from your own network. So that wouldn't be good. And then the shutdown one, as Sean said, is constantly running the shutdown scripts to make sure the shutdown button isn't pressed. But we don't want you to corrupt your SD card every time you want to unplug this thing. So if you ever want to move it to another server room or your home, you just gotta push the button, wait for it to turn off, wait for the little blinky lights to die down, and you're good to go.
one of the reasons we did the shutdown button is when you get Artillery on the unit, it is really difficult to SSH to your Pi. So, and I know a lot of people don't want to carry around a keyboard and a monitor to check on Artillery, so we did this so you can just push the button, and then just wait the 30 seconds and then move on. So, another issue we had was with Artillery logging. When we downloaded Artillery, it didn't actually create a log file, or even the directory that contains the log file. So we had to look at it and fix it on our end to get it to work with Network Scout. So what we did is we created this function, and what this will do is it'll grab the IP address and then take the message that gets emailed with Artillery. There's an emailing function, and it'll take the alert message that goes in that email function and pass it off and send it into a log file. And what we did is we added this to the bottom of Dave Kennedy's core code. So when you set up Artillery, it automatically puts this function at the end of the document, the core.py document in Artillery. And then we also made a program that opens up the Python code and injects the call for the function. So you can see here, we open the file, look through the file for a certain string. When you find that line, we add 1 to that number, so it'll put it underneath. And then we close it, or we write it and we close it. And then you have a working log function inside Artillery. And this is what the calls look like. So you have your modify program, and the function is called warn the bad guys, or warn the good guys. So it'll search for that. If it finds it, injects our function call right underneath it, and sends the same information to the log that would get sent out to the email. So we did all this to make Artillery actually log, and it works really well. So,
all right. For the server setup, we needed to discover something that would work well with the Raspberry Pis and some OS that would do everything that we wanted, and we found that was Linux, Apache, MySQL, PHP. And it's also provided in the setup scripts that will automatically download for you if you set up the server software.
So our biggest challenge with Network Scout was getting all the stuff set up. Like, you have to have LAMP if you're on the server. We had all these things going on, and when you're in the testing and development stage, you're doing this 50, 60, 70 times, and it got really old really fast. So we're sitting around, we're like, there has to be an easier way. So I got really frustrated one day and wrote a whole script to set up Network Scout. And special thanks to Just Moore. He did a automated LAMP install script on GitHub, and we pulled that into our setup script to make it relatively easy to set up. So we'll go through that. So here's the setup folder. So this is your menu options. You can set up the server or the client, or you can also uninstall Artillery right from nssetup.py. And then if you just throw some code, it'll say, hey, that's not right. It's past 4. And then this is the, I think this is the client. No, this is the client. So this will open up. It'll move Network Scout into var. So you'll have a folder created under var Network Scout. Copies all the contents, updates the GPIO, which controls the LCD screen, and the shutdown button. And then it'll open up. This is where it modifies Dave Kennedy's program, creates the directories for the log file, goes ahead and creates the log file, and then we close that. And then this is doing the init.d scripts. So what this will let you do is you can do sudo service, and you can do ns client, start, stop, shutdown, or start, stop, restart, or status. It'll also work for the shutdown button in the LCD screen. So if for any reason you need to check on the status of Network Scout client, you can just do sudo service ns scout or ns serve client status, and it will tell you, hey, this is running, hey, it's not running, etc., etc. Bash scripting. Woo! And then finally, this is really funny. I spent a lot of time trying to figure out why my sudo service wasn't working. I spent 2 days, and I was like, I don't understand, kind of looked at examples online, trying to build this. Permissions were wrong. I was trying to sudo service, start a program and didn't have permission to run it. So it would go, yeah, I started it, and then it would shut down. So I spent 2 days trying to figure this out just to find out the permissions were off. And then it'll ask you if you want to reboot it. And then this is similar for the server, so it goes through, and this is where I'll actually do the install for LAMP. Like I said, made it really simple. So we open it, it says installing LAMP. It takes like 15 minutes to put all the stuff in place, and then goes through and does pretty much the exact same thing as the client. And then we did our, this is the just printing out, moves the website into the website folder, and the other thing is we actually create the database for you. Oh, through that gate.
What?
Yeah, that way. So we put all this information in a database, partially because looking in the future, we may want to use this for a lot of other things. So we created a script that runs and automatically sets up the database, does all the tables. The ultimate goal was to make this as easy as possible, because we gave it to Bill, and he was having problems with the LCD screen. And like I said, there's just so much stuff that has to do that the documentation would be 15 pages long. So instead of writing, because I don't like to write, so I just made the script. And I'm like, here, just sudo, do the script. So, and then this is how it uninstalls. So, okay, let's see. And this is what the setup looks like. So you just go to get the GitHub /networkscout/ns. Next slide. And then, important note, you have to run the setup outside the directory. So you'll do /.
They're still on the same one.
Or you'll do networkscout or ns/ns setup. And then it's really hard to see on this monitor, so I apologize about that. But you'll have your 4 options. You pick the one. If you do server, I think you have to create a password for MySQL, and that's it. Your network scout's already done, already set up. Like I said, we tried to make it really easy because there's just so much parts that have to be in the right place. Okay, next slide. And this is the server address. So this is when you go into the client and tell it or point it to the direction of the server. You just nano the config file. Next slide. And then right here, it just has it in quotation marks. You just change the IP address, save it. That's the only setup you actually have to do on the files. Okay.
Right.
And this is a video of the attack.
Try it again. Okay.
Yep.
Alright, on the right is the website that I designed. It displays the incident number, IP address, time of attack status, and a message of what you have to do in order to fix the issue. Or, yeah.
We'll state the issue, and you can see we do a port scan here. Runs. We've been blocked. We're not getting any open ports. It takes about a minute for Network Scout to update. But when you do, you'll see we did the number as like a prime key. Like I said, if we wanted to expand this out later, shows you the IP address, the time. Eventually, we may change like the status messages, and then it shows you what artillery caught. So you can get all this on your subnetworks, reporting back to this little Raspberry Pi. So it makes it really easy to check, see if there's port scans going on, like brute force SSHing, things like that. And then for the future, one of the reasons we went through the code is because we want to open this up to the developers, and we don't want this just to be, this is our code, this is what it is. We want it to branch out. We want to see like what other people can do with it. So we kind of go through, show you how all the pieces work together. That way, if you want to go through and do some like awesome stuff with Network Scout, you have an idea of how it works. Because nothing's worse than like trying to modify a program and you don't know how all the pieces work together. So
yeah, and we also provided our contact information that if you download or the open source software that we have, you can contact us and say like, hey, I fixed this, or hey, I'm doing this with Project Network Scout now, and we want to hear back from you guys, and we really want to like let this, like, this is our baby, but we want you guys to teach it new things, because we pretty much taught it everything we know so far. But yeah,
any questions, comments, concerns?
Yes, sir. Bill?
How much does it cost to build one?
It's $127.74 for the B, or B plus, and it's about $15 cheaper for the A or A plus. Bill?
Where can you find the parts to build a Network Scout?
Amazon.
Located on github.com/networkscout/ns.
What about the hardware?
No, it's on the wiki. There's a link to
Okay,
it.
the wiki, okay.
Yeah. Bill,
Yeah, is there an image that I can download to my SD card?
were you asleep during this presentation?
Yeah.
Said image and I didn't see a image.
It's on. Hold on. Look at it. github.com/networkscout/ns. There we go. Oh. Just kidding.
Beautiful.
It's alright.
Turn this into a live thing. Just have an access point for it.
I like it.
To go with the A, what do you do for network? The Raspberry Pi A doesn't have a network.
It doesn't have a network?
It-
Okay, we probably won't
It
use
works on Wi-Fi too if you wanted to put Network Scout on Wi-Fi. But here's the wiki. So we have an issues page. You can also see a list of all the parts. So I'll show you that. It also has links on the list. So let's see. Oh, Google finally updated. So you can click on this. It'll link you to all the parts. Gives you a breakdown, what they cost, the shipping. And then we have a total, like how much it costs to build one, and then this is the total for two. Because some of the parts, you have parts left over. And then we'll go back. Go back to GitHub. So this is the guides through the how to set up, like build the hardware, and then this is the LCD guide. And then here's your zip files with the ISOs, so you can download those. And these were created on November 3rd, so they're relatively new. But that's where you can get the ISOs from. And then we have our contact information, and you can follow us on Twitter. And if you have any comments or questions or anything like that, feel free to tweet us. I have it set up to my phone, so should get an answer relatively quick. Yeah. Oh, sorry. Go ahead.
So, what have you found out about limitation and scalability yet?
So far, it seems to work pretty well. We've only had about, 3 or 4 running at once. Hopefully, you're not getting a lot of traffic or a lot of indications on Network Scout. So you shouldn't have as far as like a congestion issue to the server.
Mm-hmm.
If you're having issues with that, then somebody's really got your network.
And we kept one running for about a month span, and there wasn't any issues. It didn't overheat. The standoff screws helped it have a constant airflow around all the pieces, so everything. Like if there's like a time management issue or something, like we didn't find an issue with that.
Let me add,
Oh,
Okay.
there's a couple things in this project they're probably not aware of, but what I've done is I've actually installed these in testing in 2 production networks that are my consulting clients, and they've been running there since basically the end of the project, which would have been September or even earlier. So I think in one case maybe June, the other case September or August. Never had an issue with it. There's no problems with heat. It's based off, this image. Basically, the design is based upon an educational server that was developed by Hackers for Charity and deployed in Africa. So that's a pretty rough environment, and there's no issues with heat that we know of. There's no issues
specifically with scalability that we know of. We've tried to break it. We've run, in the case of with the ones that are in production, there's actually been gigs of traffic monitored, and well, probably hundreds of gigs of traffic, terabytes of traffic has been monitored, and we've not seen any issues. It doesn't mean it's perfect. It doesn't mean the code's perfect. I mean, you guys are beginners. I'm kind of a beginner at this. This is the first project like this I've worked on.
Yeah, that's why
And that's the reason it's on GitHub. You know, send a pull request. I'm sure that there's something, and there may be a better way of doing the web server too. I'm not a big fan of LAMP, but it's what works for this project. So please, if you have anything to add, it's an open source project. That's the reason it's open source. So if you have some help or any ideas on how we can improve the design, the problem with this project is they're going to graduate. So they need jobs. So, but they're going to graduate and go on to something else, but we hope to keep Scout doing something with Scout, and we've got some ideas, and they've got some ideas. I've got some ideas, and they've got some ideas. And as soon as I stop giving them homework, maybe they'll get to work on it over break a little bit more. But that's all I have. Does anyone else have any questions?
It can be.
It shouldn't be limited at all. I mean,
It's just like
theoretically, you can put as many scouts as you want to. That's just sort of what they've tested with. And,
that's how many scouts we had at the time, so we made a list notes up. But it should, as many nodes as you build, it should predictably.
it should scale.
Yeah, work with that many. I could show you where to change that so that way it listens up to however many you want. It's in the NS server Python script. Oh, great.
That's not
Your
it.
password's not password.
No. No.
But does anyone else have any questions?
The what Aiden's talking about in the code is that it'll listen up to 4 scouts at once.
Mhm.
And yet again, you shouldn't be having a lot of traffic coming back to the server. And we built the code to where if the client couldn't send the packets, it'll retry in 60 seconds. So, if the client can't reach the server, it'll keep that log continuously until it can send it. So you won't have any lost information there.
And I'm sure that we could make it do false positives, and we do see false positives, but generally it's been very reliable, at least is what we've done in testing and also in production. We have discovered attacks in production, so it works as far as we know. Could. One of the things we were talking about, we were looking at lunch at Fiverr yesterday, and they were like, people were offering to do like complete penetration test of your website, and I'm like, I should send them to my honeypots. That'd be worth $5. I mean, just for to see what sort of report I would get back, because after you only get one shot, it bans you. So then you're like, I think your host might be down. One of the issues you're going to have to deal with too is if you're doing internal testing, if you're running things like Nessus or even mmap on your own computer, on your own network, you're going to have to whitelist yourself, or it's going to ban you. And then it's not hard to unban. It's basically there's a script in Artillery that will unban you, but it's still not fun. And it's a huge pain in the ass when you're trying to play with it and you ban yourself. Yes, Tom.
Does it just ban you from the device, or can you script it to send that ban information to like a upstream gift or whatever?
Well, that ban actually gets sent to the web. Whenever you get banned, it sends it to the reporting server. So you see your own IP address get banned. So then you can go back through and basically unban it. That's why
That's something we were looking at for future development, is sending it upstream. But yeah, that was one of the ideas, was to send it somewhere and ban it completely.
Yeah, I mean that's one of the things we want to work on. We're pretty rudimentary at this point. What we need is more money and time, which we have neither of. So But that's also the reason we put it into the open source community. If somebody wants to write that and contribute it, that's cool. So,
And
yeah, yes, Mr. Foster. No. But, you know, you're based upon IP, but you're right. Change your MAC address, change your IP. But most client machines shouldn't be doing that. Well, I mean, here's the thing about attackers. This is low-hanging fruit stuff. You've got some super network ninja. Most people are not expecting an IDS IPS honeypot inside your network. So the idea is to advertise a juicy-looking target, so they're going to go for it. So even if you've got some cyber ninja, drink, it should detect them based upon the fact it's a juicy target, and whenever they hit it, it's going to report them. And nothing's foolproof, but I think it gets around things like signature-based defenses. It gets around putting all your money in hardware at the edge of your network and saying I'm totally safe. I'm unhackable, which, you know. Also, I just wrote a book on building an information security awareness program, and you can have the best information security awareness program in the world, but someone's going to click a link, someone's going to open an attachment. And I have all these cyber ninjas, that are my friends on Facebook, sharing stuff that I know, you know, is either false or possibly contains an exploit, and I'm like, do you really think about this, guys, when you're clicking these links? So, it's, you know, and no one's perfect. So, this is trying to fix people's imperfections in many ways. This is a technical defense against social engineering. Oh, on Amazon.com. Thanks for the great review, by the way, Wayne. Does anyone else have any questions? Yeah. Yeah, I'm looking for someone to pirate my book, which is the ultimate, you know.
I've tried to find it, and I have failed to.
I can't find it either. I'm the only person I know that owns a PDF of it. It's got my personal information and email all over it. So.
You give me a copy of $5, I'll pirate for you.
Do you have any money? Does anyone else have any questions? Well, I think that's it. You all have anything else? Nope. Thanks a lot.
Thanks, guys.